Welcome back. It's currently 6 p.m. UTC GMT on Wednesday, the 22nd of July. If I sound like I'm stumbling, it's because it's Thursday, July the 23rd over here in Australia. So if anybody wants last night's sporting results to make some fortune, I'm happy to split the profits with you. Look, without further delay, let me bring on Charles, who I hope is in the wings there. I know he's floating about with Building Faster Excel Solutions. I've known Charles a few years, and one thing I know with Charles is you don't mess with him. He keeps beating me up. So Charles, are you there? I think you've still got your microphone on.
Thanks, Liam.
No. Welcome, my friend. I will let you share your screen. So we'll just have a little bit here. So if you want to take over, feel free. I'll stop sharing. So you might see no live event for a second. Don't worry, but we are here. So Charles, the screen is all yours.
Okay, let's try pressing share. See what happens.
Don't go anywhere, everybody. In the meantime, we are here. It's exciting.
Desktop.
That's it.
Yay! How does that look?
It's just coming through now. So Charles, I'll leave it to you, and I think we'll be taking Q&A at the end here. So best of luck, and I'll see you later.
Thanks. Okay, just to introduce myself, I'm an Excel MVP, and my main claim to fame is that I'm a bit of a fanatic about trying to do things in Excel faster. And that's led me to try and understand the way Excel does its calculations, and to do a lot of experiments with VBA and C++ and stuff like that. So my website it has a lot of details about how Excel does its calculations and how you might make them go faster. And my blog, fastexcel.wordpress.com, has a lot of articles about making VBA run faster, and what happens when you try and do conditional formats the wrong way and stuff like that. So today we're really targeting VBA users, basic VBA users, intermediate VBA users, and some expert VBA users. And hopefully we're going to try and move you along a notch in VBA usage. Now the target is to try and show how to make your VBA run 10,000 times faster. Yep. And actually, I'm going to try and see if I can get it to 20,000 times. Sometimes we can, sometimes we can't. It depends on the speed gods. Then we're going to extend that out a little bit to say, well, okay, if I've got more complicated VBA solutions, I need to try and find out where the bottlenecks are before I start speeding things up. And then finally, we'll wrap up with some thoughts on life beyond VBA and a very quick overview of all the other Excel extension technologies. So the big thing about VBA is that there is a mountain in between Excel and VBA. And what I mean by this is that there's a big overhead in transferring data between the two. So you've got to take stuff across the mountain from Excel to bring it into VBA, and you've got to take it back again when you want to take stuff out of VBA and put it back into Excel. So a lot of the ways of speeding things up involve trying to minimize the number of trips over the mountain and trying to take as much with you on each trip so that you minimize the overhead. And also the green arrow signifies that if possible, you want to make Excel do the work, so you don't have to bring anything into VBA at all. Just send Excel some commands. So for example, if you want to sort some data just from VBA, you could do it by bringing all the data into VBA, running it through a quick sort routine, and sending the data back again. Or you could just simply tell Excel to sort it, and that would be much, much more efficient. So that's enough PowerPoint. Let's actually look at some real live example stuff. VBA. Here's the test problem. We're going to try the challenge of making the VBA to run 10,000 times faster on. What we've got is the set of shipments from one city to another city. There's a price for the shipment and a volume. So we calculate a value, use a SUMIF to total it up for the city. But it's time for the annual price change. So down here, we've got a list of cities and the price change that we want to make, and adding 1 to make it a multiplier. So we can use this multiplier to multiply the price and get the new price. So we've got 10,300 city pairs. We've got 105 cities. And so what we've got to do is for each city in the city list, we've got to look it up in the city pairs, change the price, next city, and so on. Now, before we start doing all that, we need to, whenever we're comparing times, we need to have something to accurately time things, would you believe? So what I use is the Windows High Resolution timer. Obviously 2 versions of it, one for 62-bit and one for 32-bit. We use a simple little VBA function called microtimer to make calls to the Windows high resolution timer. It gives us a resolution of about 1/1,000,000th of a second, 1 microsecond, which should be enough, I think. And it's actually very fast to call, so we don't get any interference in the timing results from the act of calling the timer. Now, so the first bit of VBA we're going to use to do this price change is pretty much the way you'd do if you started with a macro recorder. So let's look at it line by line. Start by grabbing the start time from the micro timer. Then we select the D2, which is the first city in the city pairs list. We, because there's a different number of cities, we select a range from D2 down to the end of that list. Then for each city in the selection, we select it. We can only do the first price change. This macro is so slow. So L2 is the first city in the city price change list. So if the city we've selected in the city list is the same as L2, then the next column, column E, is the price. So we select that, and then we multiply it by the price multiplier in column N. Increment a counter. If the counter is 20, we're going to exit because this demonstration is so slow. Right, now let's time the first one. Go to the Developer tab, Macros, Macro Style, Run. Dum-de-dum-de-dum. Shouldn't take too long. See what the speed goes, 3.5 seconds. And it's done 20 changes in 3.5 seconds. Now, 3.5 seconds is not a very long time, but of course, yeah, right, 3.5 might be a better idea rather than 3.5, Charles. Okay, so when we scale it up to the 10,300 changes, price changes that we actually need to make, it would take 1,803 seconds, and that is too long. So let's see how we can speed it up. If we take the next version, what we're going to do is switch off some things in Excel that take a long time. So here's a little routine to switch things off and on. The first thing we're going to do is turn off calculation from automatic to manual, because every time we make a price change in this, every time we change a cell in this worksheet, it's going to redo all the calculations. That's not smart. For 10,300 changes, we were going to do 10,300 price changes, 10,300 calculations. That's not good. We're going to switch off events in case that's taking some time. Another big one is screen updating. in the latest versions of Excel, updating the screen is very, very slow. So again, doing 10,300 changes, we'd be updating the screen 10,300 times. And we want to switch that off, so we only do one screen update at the end when we've got everything done. And finally, we'll turn off Excel's clever animations that sort of flick things around on the screen because, hey, it doesn't add anything to the timing. Then when we're done, we'll switch them all back on again. So this version of the VBA code is identical to the first one virtually, but I'm going to call the switch off routine at the start. Then I'm only going to do Birmingham this time, but I'm going to do all the price changes for Birmingham. And then at the end, I'm going to switch things off. Let's see how much time that speeds things up by. So we'll run the switch off routine. And 98 changes in 0.535. That's quite a lot faster. In fact, it's 32 times faster just for turning those things off. But that's a long way off my target of 10,000 times. Okay, so what are we going to do next? Well, the other thing we were doing that takes a lot of time is selecting stuff. Because every time we do a select, we've got an interaction between VBA and Excel. And as we know, those interactions are slow. So instead of doing the selects, we'll set a range variable called changes to the range L2 down, which is the cities list, and which is the cities price change list. And we'll set another range variable to be a list of cities in D2, so that's the 10,300 changes. Then we'll loop on the changes for each change in changes. We'll loop on the cities for each change. So we pick a change, we loop down all the cities. If the city matches, then we use the multiplier to change the price. And then at the end, we switch things off again. Okay, so that's getting rid of select. Let's see what the effect of that is. So we run no select. Run. This time we're doing the full 10,300 changes, and it's taken 3.29 seconds. 287 to be precise. Okay, so we're up to 500 times faster than the original. Still a long way short of the 10,000 target. So what are we going to do next? Well, we're still doing a lot of mountaineering in that last one. So here's where we make a big change. We're going to minimize the amount of mountaineering we're doing by using a variant array. So what we do is we define a variant array var change as variant, and then we get all the change data in one loop, one statement, straight into that var change variable. That will create a two-dimensional variant array. So that's going to get the change data. And then we want to get the to city and the price, that's column D and E, all 10,300 rows of that, into a two-dimensional array. So that's var city data equals that. Then instead of looping on the actual cells, we loop on the variant array. So we loop from the lower bound of the city data to the upper bound of the city data, and then we loop on the changes. We see if the change city is the same as the city that we're currently looking at. If so, we change the price in the array. And then at the end, we put the data back. So the range, we assign the var city data two-dimensional array back to the range. So that's going to do 3 trips over the mountain, if you like. Each trip's going to be carrying a lot of data, but that's 1 to get the change data, 1 to get the city data, and 1 to put all the data back again. So that should be a lot faster. Let's see how that runs. This is variant arrays. Run. Wow, okay, 0.321 seconds. Okay, so that was, yeah, 10 times faster than the previous efforts. And again, still a way short of 10,000, or only up to 5,615 times faster. Okay, now for the final push. Let's see what else we can do to speed it up. Now, before I do that, actually, let's have a look at what the big change was between the variant array version and the range version. So if we put a breakpoint in here, then we run that module, and we look at the locals window, view locals. I might need to magnify things here. So we can see that each thing, toCity, for instance, is a variant containing an object, which is a range. And change is a variant, which is an object containing a range. So they're all cell variables, basically. So if we think about that, then what we're doing is, if we think about that in terms of trips over the mountain, we're actually doing 10,300 trips over the mountain times 10,300 trips plus a few. So that's about 10 million trips over the mountain we're doing. Not surprising that it's slow. Okay, let's break out of that. And let's look at the variant array version, again with the locals. Put a breakpoint here. Run it. View locals again. And look, what we've got here, var city data, let's look at the var change data. It's a variant array. There's 105 of them, and there's 3 columns. And the city data is there's 10,300 of them, and there's 2 columns. So we've got all the data across the mountain in one fell swoop, and we're just going to be looping on the arrays. And that's why it's so much faster. Okay, but we've still got to meet our challenge of getting to the 10,000 times faster. We're only at 5,000 odd at the moment. Here's the final version. Probably isn't actually the final version. I'm sure I can always think of ways to make things faster. But what we're going to do here is, this is more like a proper version. We've got option explicit at the top. That makes sure that all our variables are declared. And we're going to declare the variant variables as variable. We've got a jcity and jchange as long. These are indexes to run through the loop. We've got times as doubles and counters and so on. And then what we've got is 2 additional arrays. This is an array. It's going to be an array of cities, and it's going to be declared as string. An array of changes declared as double. We've been using variants up to this point. Variants are wonderful, but they're quite complicated beasts because they can hold numbers, doubles, and so on. They can hold strings, they can hold Boolean variables, they can hold errors, all sorts of stuff. So whenever you're manipulating a variant with VBA, first thing it's got to do is work out what on earth it is inside this variant variable, and then probably it has to convert it to the appropriate type before you can manipulate it. Now, you can't actually multiply variant variables together. You first of all got to convert VBA under the covers, has got to convert them to doubles, then do the multiplication, and then convert them back to a variant again. And all that work is slow. So what we're going to do is declare two dynamic arrays, essentially, in VBA. We've declared them up here just as arrays without dimensioning them. And then we'll redimension them to be the right size. And so then we loop down the changes, changing the city name to a string, convert it to a string, put it in the cities in the string cities array, and then we convert the change percent to a multiplier by converting it to double, adding 1, and putting it in the changes array. Then we loop on the things as previous, except that, again, a little trick, we're only converting to the two cities to string once, because that's all we need to do. Okay, let's see how fast that runs. Can we break our 10,000? Let's see what the speed gods have given us today. Okay, 0.084. 0.084. Ah, I put a comma in there. And of course, small problem, doing all this messing about, I've switched it back into manual mode. I should actually switch it back into automatic mode. Right. Okay, right. Well, we've actually made, we've beaten the 10,000. We've beaten 15,000, which was our initial target. Today, we've made 21,458 times faster. Yay! Pretty good going. Now, the thing is, all this is very simple set of changes, really. Perhaps the last one was a little bit more complicated. And the point is that in real life, you wouldn't need to get it down to 0.08 of a second. You'd stop when you got it down to 0.3 of a second or 3 seconds or whatever. But if you're doing something that's much more complicated than this fairly simple example, you might need to employ all these techniques to try and make things faster. But the point is, only make things as fast as you need to make them. Don't go on optimizing just for the sake of it. Okay, that's the end of this example.
So we want to go to a different problem. So here's a different thing. We've got some data on water levels and the flow that results from that water level. The higher the level, the bigger the water flow. And the data we've got is every half meter. But of course, what we actually want to do is get some results for intermediate values. So we have to calculate a linear interpolation, a very simple little straight line interpolation. And we're going to do 20 interpolations, that's these ones. And there are 10,100 data points. We're going to do this with a VBA UDF. And oops. Let's get rid of that project. Okay, here we go. So the first one we're going to do is do things cell by cell. We know it's going to be pretty slow. We use a width the table array to make sure we minimize the amount of dots that we're using. And we say loop down the cells, looking for the first cell that's larger than the lookup value, and then exit the loop and do the interpolation between that row and the previous row. Now we can't run that directly, so what we have to do is to select the cell, the formulas that we want to calculate, and use this nifty little calc range thing to calculate those cells only.
and it's taking 786, 787 milliseconds. I mean, for this example, that's fast enough. But often when you're using VBA UDFs, you tend to have, several thousand of them, and then things can get very, very slow. Anyway, okay, so we want to speed that up. So we can do the same kind of thing as we did in the previous example. We can get all the values into a variant array. I'm using .value2, which is faster than the default, which is .value. And we're going to get in the variant array, loop down the variant array, and do the interpolation. So let's see how that runs. CalcRange actually does the calculation 3 times and picks the middle of the 3 values just to eliminate some of the variation that you get. Okay, 265 milliseconds. So actually it's not that much faster than the cell by cell, which is kind of surprising. In the previous example, working with variant arrays was a huge speed up. But of course, there's more we can do. The thing to think about is that when we look at, no, I don't want to do Alt F10, I want to do Alt F11. When we look at what we're doing with this loop, it's very much like a lookup. We're going down the column, finding a value. It's exactly the same thing as a standard lookup or match. So why don't we make Excel do the work for us? We'll use worksheet function match instead. So we'll get the column, which is the lookup column, from the table array. Yeah, I should have explained something else, shouldn't I? There are 3 parameters on this UDF. First is the lookup value. What value do we want to find? Then there's the table array, which is all this level and flow stuff. And the third is which column number do we want to pick? We just have an option to pick the first flow or the second flow. So we get the first column out of the table array, which is the levels, as a variant array. Then we can use worksheet function match to look up the lookup value in that variant array. And since it's sorted ascending, we can use the approx match thing, because that's exactly what we want to find. So let's see how much faster this is. Variant match. Okay, 28 milliseconds. That's really a lot faster because the amount of data we transferred into the UDFs is a lot smaller. We've made sense of making Excel do all the work for us. And the Excel worksheet functions are, of course, very fast. But we can make that faster, even faster. Because what we're doing here is we're getting the data into a variant array, and then we're passing the variant array back to Excel again. Well, that's a bit silly because the data's there in Excel in the first place. So if we make a range variable that just points to that first column in the table, then we can pass the range variable back to the worksheet function match, and that data never gets transferred across to VBA at all. And the range object is a very small thing, so it's very efficient to pass that back to Excel. Okay, range match. How are we going to do on this? 1.5 milliseconds.
So that was kind of interesting. So we've got a case where in the previous example, it was really super efficient to get everything into variant arrays and loop down the arrays and process them. But in this case, it's much more efficient to actually make use of the Excel worksheet functions and not to transfer the data into VBA at all, just use a range variable that we pass back to the worksheet function. Okay, let's go for one more example, which is we're going to open this one. So the question is, when we're using VBA, which is faster to find things, using match or variant arrays or find? So based on the last example, we'd expect it to be fastest to use match. But there's a bit of a twist in this example. And maybe you know, the natural thing to do would be to use find. What we're going to try and do is we've got 100,000 rows of data, so that's quite a lot. We want to count the rows where the op1 column contains an X. So that's an X, that's an X, that's an X, that's an X. And the op2 column on the next row contains a Y. So here's an example. We've got two quantities. So you want to count every occasion where we've got an X there and a Y on the next row. So if we look at let's get rid of that one. So if we look at how to do it with find, we get a range, we find out how many rows we've got to count. We set the range to find using a wildcard match the X, first X in values. If it's nothing, if we have found something, so that range will not be nothing, that gets us the address. And then we look if the next row contains a Y. And we found it, so we increment the counter. And then we do a loop using find next. So we're moving on, we're not doing a find through the whole thing. Again, we're starting from where we left off. And we continue until nothing is found and the range address is not the first address, so we've looped back. Okay, so if we run that one, I'll run it from inside Excel here. That's taken 4,000 milliseconds. So that was the find. 4065. So it doesn't sound like find's very fast. So if we go back to, we could do a for each. This should be pretty slow, right? This is the kind of thing. So we're looking at each cell in the range using for each cell in the range, p size to be the whole lot. If somewhere in the middle there's an X, then if somewhere in the next row's got a Y, then we count it. Okay, let's time that one. 292 milliseconds. It's a lot faster than find. It always surprises me that I do not know why find is so slow. You really wouldn't expect it to be. Now let's look at worksheet function match. That might be a good bet. It was certainly quite fast last time around. So we set the range to be what we want to look at. Number of rows is the count of the number of rows in that range. We use it with worksheet function. We do the match on the range. Variable should be efficient. Check the next row. And then we reset the range to be the remaining rows because we don't want a match to keep starting at the beginning.
We loop through. That's taken 702 milliseconds. So surprisingly, that's slower than 4 each. And I think this is because there's quite a high overhead in calling a worksheet function from VBA. And in this case, obviously we've got to count, we've got to do a lot of calls to the match to find that. If there was only one case in this 100,000 rows that met the criteria we're looking for, an X and a Y, then match would have been very fast. But since we had to do it lots of times, the overhead of calling the match has outweighed the efficiency of using match. Okay, let's look at the next one. Let's do it with a variant array, see how that works. Okay, so we get the data into a variant array. We loop down the rows. We look for the X and the Y, and away we go. 67 milliseconds. So that's the winner, easily. Quite surprising, and it beat the other versions. Particularly find. Find's really slow. So, right, we're running slightly over time, but not to worry. So let's see. I think I just want to show you very briefly is this. Okay, we'll open it this way. When you've got a big, complicated VBA project, and I'm going to use as an example my Formula Explorer thing, which is about 40,000 lines of VBA. You've got to find out where the bottlenecks are before you can start applying these speed up techniques. And it's not necessarily an easy thing to do. So built into the profiler, the FastXL profiler, is a method of profiling the VBA. You start by adding some profiler calls. And we'll choose the project that we want to add profiler calls to, and we'll add calls to every single procedure in the VBA. And okay, 3,856 calls. We've got a lot of different subroutines and functions and stuff in this. I want to leave the profiling switched off. Okay, and I'm just going to run this. Formula Explorer thing, and then what I'm going to do is I want to time a particular action. I'm going to switch on the profiling, and then I'm going to click on one particular thing, which is going to go where it's doing thing, and select the result of that criteria, and then we'll show the profiling report. Oh God. It's gone away, isn't it? Okay. Now, so this has shown us for all these the subroutines and functions that have been called, and it's totaled up the time that each of them are using. We can see where we're at. Okay, in this case, there's nothing that's really standing out, but we've got one particular function that's taking more time. We can go take that a step further. Kill off that. I can go back to the profiler, and we can get rid of all those profiler calls in the VBA. and then I can add profiler calls to a specific function. So I might pick function inside the user form. I'll get there in a minute. And yeah, use, let's pick that one. And then I can add calls every 5th line. So then when I run the profiler again, or I can look at the VBA and it'll tell me every 5th line, every 5th block, every block of 5 lines, it'll give me a time. So I can narrow down, drill down to within the specific function and find out where things are taking the time. Okay, now, right. So that's really how we've been working with work to my PowerPoint, right. So we've done all the VBA profiling stuff. We've learned how to figure out to go through the mountain. Summary. We switched off screen updating, calculation, avoiding select and stuff like that. We avoided mountaineering with the variant arrays. We used .value to rather than value or text. Made Excel do the work. Range variables with worksheet functions, doubles, string comparison, stuff like that. Nothing very complicated, but you've got to do experiments to find out what works for your particular case, because the answer isn't always the same. Now, okay, enough VBA. What about life beyond VBA? Does it exist? Well, there's a new kid on the block, which Sudhi Ramamathy is going to be talking about tomorrow. It's called Office Scripts. This is Microsoft's view of the world, of the Excel extensibility scenarios. We've got an axis running from desktop and individual through to web things and collaboration and stuff like that. So we've got a professional developer audience or an end user approachable audience. So VBA, yeah, it's desktop stuff. It's end user approachable. It's great. For pro dev, yeah, we've got more things like the COM add-ins and so on, using VSTO, other tools of that kind of ilk. And for the new kid on the block for the web add-ins is using JavaScript. And again, we've got Kaya talking about that either later today or tomorrow, I can't remember which. But the new kid on the block, really new, is Office Scripts. This is the first time that in my lifetime, the last 20 years or so of working with VBA, that Microsoft have attempted to do something comparable to VBA. And this is quite an exciting thing. And it's early days. It's quite promising. I really encourage you to look at what Sudhi is going to show you tomorrow. Looking underneath all this a bit, there's various API technologies that are used. We've got the COM automation API, which is what VBA and uses and VB6 used to. Sitting on top of that is an interop layer, which .NET tough stuff like VSTO tends to use. That means it's slower than the COM layer. We've got the XLLC API, which you can get at from C++, Python, .NET, as Govert was talking about, Python, as Tony Roberts was talking about, and R, which Gregor is going to be talking about later on. The nice thing about these kinds of technologies is they tend to use both the COM automation API and the C API. C API is the fastest one. So if you want to write fast user-defined functions, that's what you use. But it doesn't have as much, the API is not as rich as the COM API, which has got about 4,000 different calls in it. JavaScript is a new API. They're still extending it. They've got to about 3,000 odd API calls. So they've got a little bit of way to go, but they've covered, the vast majority of things you'd ever want to do. It's a bit slower than the COM, but it's okay for most things. And then OfficeScript is, if you like, is a layer that sits on top of it and tries to make life simpler for typical VBA kind of users. So if we look at the corresponding tool sets, we've got VBA for COM, we've got VSTO for interop for COM, XLDNA, as Robert was talking about, Pixel, as Tony Roberts was talking about. XLL Plus is a tool I use when I'm writing functions in C++. And Gregor is going to be talking about BERT, which also uses the XL API. JavaScript, Office add-ins uses the JavaScript, and TypeScript use the JS API, and OfficeScript sits on top of them. Very quick overview. So these are the sessions. If you've missed them, I strongly advise you to look at them on the flashbacks. Tony Roberts did a great session on Python. Govert gave us a very good overview of why XLDNA is a good approach to working with .NET. Kaya is going to be talking about Office add-ins and JavaScript, TypeScript. Gregor for BERT, which is, can't remember what it stands for now, but anyway, it's R. And Sudi tomorrow with Office scripts. Okay, I'm just about caught up to my time frame after those odd little diversions. Don't you just love Teams? So, evaluations, please. And sign up with Microsoft Excel. And any questions?
Thank you very much, Charles. I think Patrick's got a couple in a moment, but I just want to go through a couple where we were I'd asked nearer the end of the time, and I'll mention at the end as well when the other sessions are that are still coming up. But Peter Bartholomew asked earlier, how would XLOOKUP as an array worksheet function serve to find the X's that you showed earlier?
Well, you'd use XMatch instead of the match thing. Though there's not much difference in performance between XMatch and the new speedy versions of Match. So yeah, it would be fine. Okay.
The other one I've got is from Vincent here. Thanks for the presentation. You seem to use C++. We're probably run out of time here. One of the things I was going to ask, could you give us examples of a case of C++? I don't know if we've got time here for that, Charles, but I wanted to just ask with everyone here. I'm thinking what we might do, and I know Patrick's got a question he'd like to ask in a second as well, is if you're agreeable, we are recording these sessions, and Charles, I think, is happy to have his recorded session available for playback later. What we might do is, Charles, offline, we might talk to some product team and ask you just to re-record the first 15 minutes, and we'll combine that with the rest of the session so that there'll be a recorded version that flows nicely through. If you're happy to do that when you have some time in the next few days, because it's going to probably be early next week before we can put the recorded videos up anyway. Would you be happy with that? Yeah, so please apologize. I do apologize. I didn't go anywhere for everyone who thought I had vanished. It's just the fact that I do deal with queries. I was listening online, but hadn't noticed the video hadn't updated. So thank you, Patrick and Michael, for stepping in. Patrick, I thought I'm conscious of the time. I know you have the ability to turn yourself on and off. So rather than me read out your question, if you wanted to ask, I think one of your questions, I think we'll have to wrap up after that.
Yeah, thank you for that. One quick question, Charles, and look, you can do it offline if you wish. For efficiency, talking directly to Excel for your filter thing with the *X, *Y, would that be more efficient to use data filter with those two wildcard criteria? And then you can copy just the filter rows out. Obviously, you turn screen updating off so you don't get any visual delay.
I don't know is the answer to that.
Okay.
The nice thing about Excel is that there's always about 25 different ways of doing things.
Yes, yes.
And
Okay.
some of them are faster than others. So you'd have to try it out and see. And I haven't tried that, so I don't know.
Yeah, okay, thank you. Well, thank you very much, Charles. It's 1 o'clock. I have to go, so I really want to hear John McDougall later on OAuth 2, but I'll catch up later. Thank you very much, Liam and Charles.
Okay.
Thanks.
Thank you, Patrick. Okay, so I just wanted to mention as well, thank you very much, Charles, as well. Charles has been mentioning some of the other sessions here. Just I'll give you the times of those that are still coming up. So the first one that Charles was actually mentioning was Kia Patel's session on building add-ins for Microsoft 365. That's after the next session. So that's going to be at 8 p.m. UTC tonight. Another one that Charles was talking about was, and apologies if I get the pronunciation wrong here, was Gregor Stalecki's How to Use R Language in Excel. That's tomorrow at 10 a.m. On I was going to say 10 a.m. in the morning, as opposed to the other 10 a.m. And we've also got Sudhi Ramamurthy's is the last but two session, Office Scripts, is at 9 o'clock GMT on Thursday. Charles, you did a brilliant job with us all heckling you and coming in, and I apologise for the substandard performance I gave you there. It's just unfortunate. I was here for all those who are asking. Thank you very much. We're almost at time. We've got one other question from Vincent, and I did promise I was going to ask this. Will the example file be available on OneDrive, please, so we can replicate it? And yes, Vincent, I can ask that.
Yes, I will put them up on OneDrive. I haven't done that yet.
No, just a little side. Thank you. We are going to. We know some people have been having a bit of a problem with the Bitly links and OneDrive. We are working behind the scenes because people are really keen and enthusiastic to get the stuff straight over. We're going to put it up a slightly different way. I think next week. We're just working it out. Please, 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 rather than email us and say where is everything, give us a couple of days after the conference to just get everything edited and sorted out. We'll give you some instructions with what we think will be an easier link. Charles, once again, brilliant presentation in the face of our adversity and my incompetence. Thank you very much. I might take over screen sharing for a second, if I may.
Please do. I'll stop.
I was going to say, I didn't think there was going to be any. That was always going to be a bit of a fight at that point, wasn't there? So hopefully that will come up in a second. I'm only going to be over now. I'm going to be completely honest here for the next session that's coming up here. We've got it's Alessandro Travato. Now, I'm not even going to try and pronounce this. I only speak two languages, English and Profane. So I gather the loose translation of this is new functions not required. Alessandro is going to be presenting in Portuguese at 7 p.m, which is in 1 minute's time. So we're going to go straight into it in a moment. He's asking he'll take questions at the end, and also just saying if you do ask questions in English, what might happen is he may take them offline and come back to you later if that's all right. Given I can't ask questions in Portuguese, I'm certainly not going to try, although that will be, I think a lot of people pay good money to hear me do that. His English is a lot better than my Portuguese. So we're almost at time. Thank you again, Charles. And just wait for it to turn 5 o'clock. It's 5 o'clock. It's 5 o'clock my time, 7 p.m. UTC GMT here. It just turned there. Alessandro, are you there? I think your microphone's still on mute. Yes, he is.
Hi, Liam. I'm here.
Hello. Look, I'm going to keep your English to a minimum, my friend. I'm going to let you just say, feel free to share the screen. And I promise I'm watching, but I've got to be honest, unless people give me comments in English as to what the issue is, I may not be the most proactive moderator on this one. One question we've had from Vincent just before we start is, are you going to activate a transcript in English function of Teams for this session, Alessandro?
Okay, thank you, Liam. Sorry, my English is not good.
No.
Then I prefer to speak in Portuguese, okay?
Yeah, that's fine. Just one question before you start is, are you able to activate transcript in English function? I don't even know how to...
Okay, sorry. I can see. 1 minute, please.
No problem. I think that might be beneficial, and I think people will be happy to wait for you. It's okay. So thank you, Vincent, for that. That's a good question.
Okay. Can wait a minute.
No problem. Take your time.
Can you see my screen?
Yes, please share your screen. I haven't seen it yet. I do now.
Okay. Oh, sorry. Again. I'm nervous. Okay.